Welcome everyone again to this video. It's basic vectors. This is maths memory, and again we're going to show you how to create step-by-step revision cards during this video. So let's get your card. Let's write these two key objectives on your learned category over here. So we're going to show you how to identify and understand and apply parallel lines in this topic, and also use and apply ratios. These two come up a lot. So this is basic vectors. It's a grade 7 topic. It's higher tier only, and it's heading towards, well, it's a silver topic actually. There is advanced vectors, but that's more a gold topic. Create a space for your example, the basic example during this video, and hopefully we can show you some steps as we go along. Let's turn over to our toolkit for this. So let's create a revision card and call this My Toolkit. This is where we show you two clear spaces, A and B, and two clear methodologies that will you'll find very helpful during this video. So press pause, make a space for these two categories, and we're going to head off with our core questions in a sec.
Question 1, core 1. Press pause and let's write this question down on vectors. It's quite a simple question, but it's there to show you this basic element of mid-values and parallel lines. So press pause, press play when you have got the answers for parts A, B, and C. Now ABC is a triangle and M is the midpoint of AB. These are your two vectors over here. Okay, the vectors are represented by this arrow on top. So they get from A to B, the vector is 4P. C to B, the vector is 2Q. Express AC in terms of P and Q. All right, so how do we get from A to C? Imagine these as three different, let's say, towns or cities if you want to. Vectors are nothing more, nothing less than a navigation system, okay, which cars use, ships, planes, things like that, okay. Even your sat nav in your car might have it, okay. Use vectors. So they describe two things: vectors, a direction and a magnitude. Anyway, let's talk about this. So how do we get, let's say, from A to C? So we're going, basically, we don't know what A to C is directly, so we'll take a detour. We'll drive to this town B, and then we'll drive to C. It doesn't matter how we get to C. We can go anywhere we want to as long as we end up getting to C. So we're going to go A to B plus B to C. So A to C will be represented by, first of all, A to B. Okay, we're going to get this town plus B to C. So A to B is simply 4P, and B to C will be not 2Q but minus 2Q. This is how simple it is, okay? If we do this on the vector, we're going to get this. Now, there are two things you should realize at the end of a question. You should always have the positive, let's say, vector first, or the positive term, should we say, and should factorize it as well, okay? So this is already a positive term, 4P. So what we'll do, we'll factorize this. 2 goes into both 4 and 2. So 2 and 2P minus Q, that will be your vector, okay? And if you really want to understand this, this over here is your magnitude, or scalar we call it sometimes, okay? It's how long something is, how big something is, the size of something rather. And this bit over here is your direction, okay? Your direction or your gradient, which is always the bracket. We'll come across this when we look at parallel lines in a minute. All right, so M is the midpoint of AB and N is the midpoint of BC. Let's plug them in straight away. So we'll call this bit over here, we'll call it M, and we'll call this N over here. All right, so these are two different midpoints. Midpoints lead to ratios later on in this topic, but we'll just call them M and N and highlight it in green so you know what we're talking about. All right, it's half and half if you see it like that, okay? A to M is half and M to B is half. Find M to N. So M to N is simply going to be this. So M to N is going to be M to B plus B to N. Very simple again. Now it's the same concept. So M to B will be half of AB, i.e. 2P. And B to N will be simply half of BC. We have them in part A, so that will simply be Q. So this is your final answer, okay? If you want to put a bracket there, you can. And little 1 outside to show you your two components of your magnitude and your direction. Again, we talked about them in part A. So this over here is your magnitude, and this over here is your direction. Okay, it's very important to understand these two things, these two components, because it'll help you when we talk about parallel lines. And now we're getting into part C, parallel lines. Show that both MN and AC are parallel to each other. So parallel basically means two lines that are share the same direction. And direction basically means the things in the brackets, to cut it short, okay? So what I'm trying to do is try to find these two separate vectors, mn and ac, and show separately that they both have the same bracket, okay? The bracket means same direction, all right? Or same gradient, if you think about it in linear graphs. Anyway, let's do mn over here. So mn, what do we have here? Now part B stated mn, it was 1, 2p plus q. 1 was your magnitude, 2p plus q is your direction in your gradient. So we already know that AC needs to have this 2p plus q. We don't really care about the number outside, the magnitude. We really want to understand this. Let's look at AC. Now AC, this was given in part A in fact, and this was 2p minus q. It's worth mentioning as well in vector questions, normally we build up the question, okay? It's called scaffolding. So we use parts A and B to find out part C, okay? So we always use our previous answers to do the next questions. Take that in mind, okay? So you're doing the whole thing again in part C, look back. Okay, so we've got these two things. Now, are they parallel to each other? Yes, because obviously they share the same bracket, okay? The bracket over here is this. To put it more formally, they share the same direction, which makes sense as well. You could also say that this is 1 here, and this is 2. Obviously, AC is double this vector mn. All right, so look at that and make sure you understand it in terms of this. And we can write in the question as well, both parallel because they share the same direction. And direction is, or are the terms in the brackets, 2p minus q. You can also say this if you want to, hence multiples of each other, which they are, they go into each other, which makes sense if they're parallel. Okay, and therefore parallel. So make sure you get that, understand that. We'll do a bit of a color code as well if you want to show which one is which. Mn is this one over here. And the other one over here is going to be AC. Okay, they're both obviously parallel to each other like that. You can see the yellow and the green line nicely parallel.
So we have learned parallel lines already during this basic vectors video, and you should have picked up this concept just now. So we're trying to show you how to identify parallel lines. Basically, all you want to do is to show the same things in the bracket. We've made it a bit more concrete, should we say. We have a magnitude or scalar, should we say, and direction in the brackets. Direction or gradient or whatever's in the brackets, in p minus q in this case, you've got to find them equal to each other, create two separate vectors and make these brackets the same. That's how you prove two lines are parallel. Press pause and make sure you get this.
Question 2, core 2. Let's write this question on vectors. Again, it's quite basic, by the way, shifting up the level quite a bit from the first question. So parts A, B, and C, we're going to show you definitely how to use ratios now, and something about extending lines. Press pause, press play when you're done. ABCD is a parallelogram. We clearly see that, obviously, from these little arrows on these four sides. R is the point on DB, such that DR to RB is 1.3. So that means DR, which is, let's say, one part, equates to RB, which is simply 3 parts over here. Now, when we have this ratio, it's the first time we're seeing this, always write these sections, we call them parts, on the actual line. So DR, that could be, let's say, 1 part over here, and RB, 3 parts. Just roughly, doesn't have to be exact, but so you know this is R in the middle over there. Now, DA equals 4P, we can see that, and CD equals 6Q. Now, let's find vector BD. So BD is this, B to D. Now, to get to BD, we can either go from B to C, and then C to D, or B to A and A to D. It doesn't really make a difference. Let's just go to B to A first, okay? So that comprises of 2 different separate vectors. B to A first, plus, therefore, A to D. Okay, always write these down in terms of what you're trying to achieve over here first. Okay, then we'll get into the nitty-gritty of the actual vectors that define them. So B to A, now B to A will be the same as C to D. They may not put that in the exam, but it's obvious because these two are parallel lines, okay? And it's worth writing that this is 4P, by the way, C to B, because it's a parallelogram, okay? The word parallelogram. Always label your parallelogram or shape first if they don't give you the vectors. Now, B to A, as we said, is going to be 6Q, and A to D, well, this will be minus 4P because we are going backwards, okay? DA is 4P, AD is minus 4P. Now, remember two things we need to do: have a positive term first and factorize it. So we have the positive term, i.e. 6Q. Let's factorize this. So 2 goes into 6 and 4, and this will be 3Q minus 2P. So we have clearly defined here two separate things. Your magnitude, which is your size, so that's the number outside the bracket, and the bracket simply defines your direction. So once you understand that every vector has got to be, well, not got to be, but it's helpful to represent it in terms of a number outside, and then the bracket, which is your direction. Part B, let's do this. Now, show that RA is parallel to half Q plus P. Now, this word show, as you already know, in any exam context, not this is topic, show basically means you want to derive this vector half Q plus P. You're not meant to use this as your source and work with it. You're meant to try to derive it in your own way, and this answer should be the answer to your working out, okay? That's why we call show snap, S and S, show and snap begin with S. Anyway, RA. Now, RA is parallel to this. How do we do this? Let's just work at RA first of all and compare it to this. Okay. Now, RA can be, we can get to R to A in two different ways. R to B plus B to A, or R to D plus D to A. So this is probably better. R to D plus D to A. Why? Because we're using part A in the answer to part B. And remember, we talked about that being quite beneficial. So RA would be these two components, RD plus DA. RD now is a quarter of BD, hence that's why we're using this. It's a quarter because we have 4 parts, and 1 over 4 is a quarter. DA is simply going to be 4P. So let's write this down. So RD would be a quarter times our answer to part A. A was that, so I'm going to show you the long way over here, 3Q minus 2P. If you want to, we'll put a 1 there. It'll make it easier as we go along with this. Let's get this one number in front, one coefficient in front of this bracket. So 1 times 2 is 2, 4 times 1 is 4, 2 over 4 is simply a half. So it's a half 3Q minus 2P. Okay, this is still RD. Now let's do DA. DA will be 4P as we've shown over here. If you want to, we'll highlight these to make it easier for you to understand. RD is this over here. Okay, that's RD, and DA was simply the one over here. DA would be 4P. Let's now multiply this bracket, this, like we call it, half crab claw. So we do half times 3Q. Put a 1 in if you want to underneath it, it'll help you. So it's simply multiply fractions. We're going to get 3Q over 2 minus, now, minus 2 divided by 2 is minus 1, so minus 1P, or minus P plus 4Q. Remember, this is over here. The first part, RD, and DA is this over here. Let's add all like terms, so all the Q terms. We'll do that. We get this. So this is basically 3Q over 2. We only have one lot of those, so 3Q over 2 minus 1P plus 4. Sorry, this should be P over here, shouldn't it? Not Q. Apologize for that. Minus 1P plus 4P will be plus 3P. That makes more sense. Let's factorize this. We take a 3 outside, and this will therefore be a half Q plus P. And this should be spot on with what we have over here in this. Okay, the same brackets in the same direction, hence they're all parallel to each other. And let's just highlight that so you know what we're talking about. This is your direction, and this is your direction. They both snap. Part C. Let's look at this question now. Line DC is extended such that point E lies at the end, okay, the end of line DC, and that's the ratio CD to DE is 3.2. So again, we're talking about a ratio over here. This part, CD, has 3 parts, and this one over here, DE, has 2 parts. Now, we already have CD already, okay? So CD, perhaps we can show this with a line like this. We'll do the green line. So CD is this, okay? And this is 3 parts. Now, DE is extended, so it's 2 parts off that. So is basically just 2 parts over here. All right, so if this was 3 parts, here, 1, 2, 3, approximately, this would be 2 parts over here like that, and this would be defined as E. E is the last bit of that line, okay, the end of it. Now the question is saying, how do we get from R to E? So R to E. So if you follow this line over here, this is what we want to really do over here. We want to get from R to E. Okay, R to D first plus D to E. That will give us what we want to do. Let's define those 2 components. So RE equals RD plus D to E. Before we do that, let's define CD. CD was 6Q, hence D to E. If one of these little bars or parts is worth, obviously, 2Q, because, 6 divided by 3 is 2. This must be 2 times 2. This whole thing, DE, must be 4Q as well. It's worth writing that in a second. We'll be using that information. So RD, now we have RD already. RD is already something we worked out at the beginning. It was this yellow bit over here. So RD would be 3Q minus 2 minus P. Okay, that's your RD over here. And then we want to do D to E. And D to E is simply going to be plus 4Q. Let's add all like for like terms together. So we have now 1.5 plus 4, which is 5.5, or 9 over 2. That's a funny 9 over 2. There we go. 9 over 2 cube. And this will be minus P. So that will be a final answer for this question. But make sure you understand how to extend lines and, create a vector from that. So there we go. These are your answers for this topic, or the question rather.
Here's a second revision card. It's on the toolkit, part B, ratios. So you have just learned how to deal with ratios, and this is very, very typical on these type of basic vector questions. A very top trick is to add these numbers. In this little example, we added 1 plus 3 to get 4 boxes, we call them. In this way, if you can visually show this on your diagram, it's very, very powerful to show these boxes. And again, as we said, this could easily come up. So press pause and make sure you get this.
Question 3 challenge. Let's write this question, more challenging question on vectors, parts A and B over here. And let's press play when you're ready. Now, ABCD is a quadrilateral, okay? So it's not telling you what kind of quadrilateral. It doesn't even have any parallel lines or sides, should we say, but it's just saying a quadrilateral. AB equals 6P minus 3Q. All right, so it doesn't give us any vectors. Let's write this down. In fact, AB is 6P minus 3Q. CB is 6Q. C to B is 6Q. And D to C is 5Q. So if it doesn't give you any vectors, write them down. Sometimes it doesn't give you that. Now, T is a point on CA such that C to T, let's just give these color coordinations. It's easy for you on the eye. So C to T to A is 2 parts to 1 part. So if C to T is 2 parts, T to A will simply be 1 part. Okay, remember this kind of ratio technique. Now find D to T. The question is saying D to T. Now where is that? D to T. Well, before we do that, let's just create this line CT and TA so we know what we're talking about on CA. All right, so we've got CA over here. And where is T on this line? So we have 3 parts altogether. We have C to T is 2 parts and T to A is 1 part. So 3 parts, because 2 plus 1 is 3. We'll just write this as 3 parts. So 1, really roughly 2 and 3. Okay, and this point over here should be T. Now D to T will therefore be this one over here. We want to get from D to T like this. So how do we get to D to T? So there are 2 parts. We could do obviously DA plus AT or DC plus CT. Now before we do this, let's try to figure out first of all this vector C to A, okay, because I think the better way of doing it is DC plus C to T, but we need to find out C to A first. So sometimes they give you a question that gives you this build up. So you find the whole length. Here they don't. They expect you to know, to find out C to T. We have to do C to A first. So we'll just do this. So let's define D to T will be D to C plus C to T. Now let's find CA first, because obviously CT is 2/3 of CA. Alright, so CA is the first vector we need to find out. CA will simply be 6q minus this vector, or 6b plus BA. Let's just say that, okay? Let's put 6b plus BA, which turns out to be 6q minus 6p minus 3q. We can put an imaginary 1 there and half crab claw this to give you 6q minus 6p plus 3q, which would therefore give us, if we add all the q's together, 9q minus 6p. Okay, or if you wanted to write it like this, 3q minus 2p. All right, so that is basically C to A. Now let's get back to this question. We want to find out CT. CT would be 2/3 of this. So CT would be 2/3 of 3. Now 2/3 times 3/1 is simply 2. We haven't done the working out there, but just imagine, obviously 2/3 of 3 is 2, hence the 2 over here. So again, we write what's in the bracket and we multiply this out. This is simply CT. So CT is going to be 6q minus 4p. Right. Now, after all of that, we've got to CT. Let's add DC to it, because that was the original one we wanted over here. So the final answer would be this. DC is 5q plus 6q minus 4p. Part B. Line CA is extended to this line over here, such that the point O lies on this line, and that TA dot AO is 1 part to 4 parts. So TA, if this is 1 part, AO would be 4 times longer, i.e. for this part. So let's try to extend this line and incorporate that information. Let's start with CA, in fact, over here. Okay, so from here, we're going to go double this and a bit more, okay, because for 1 part of this, of TA, like that, we'll have 4 parts for AO. So 1, 2, 3, and 4. And this bit at the end will be called O. Alright, so that's AO over here. That's the first thing to understand. Now we want to show that BO is parallel to this vector 5q minus 6p. BO is over here. B to O. Now how do we get from here to here? That's all we need to do. So this is 2 parts. We're going obviously backwards. We're going backwards into, when I say backwards, I mean we're doing the negative of this. We're going B to A plus A to O. So let's just define that. So B to O is defined as 2 components. It's B to A plus A to O. So B to A must be the negative of this. So if we write this over here, B to A, that's going to be minus 6p minus 3q, which is going to be, there's a minus 1 there, multiply this out. I'll put the positive number first, so 3q minus 6p. Okay, so that's given us from B to A. Now what we want to do is go from A to O. This is slightly trickier, A to O. Now look at this, C to A was defined as this, okay? Just take this into account. C to A was defined as this from part A, 3q minus 2p. We saw that from over here. If you look at that, I want to highlight that, in fact. This was C to A. Now this is C to A over here. We want to find out A to O. C to A had 3 parts, A to O has 4 parts. So therefore, if this 3 represents the 3 parts, surely A to O must represent not 3, but 4. Okay, because we're extending it by another part or a third on that. So basically, we could say this. We could say A to O, this would be defined as 4 and 3q minus 2p, because your direction is still the same, but we've extended it by an extra part or an extra third, if that makes sense, like that. Now let's get back to the question over here. The question said to find B to O. We've done the first bit, B to A. B to A was this. So b to o was 3q minus 6p. That's taking us to a. And we're going to add this bit over here, plus 4, 3q minus 2p. Let's expand that. So it's 3q minus 6p plus 12q minus 8p. Let's go one step further. All the like-for-like terms for q. So 3q plus 12q. This is 15q. And all the p's minus 6p minus 8p over here. So this would be minus 14p. We have this, and this would be the final answer. We can't factorize this anymore. So 15q minus, 15q minus 14p. That would be a final answer for this. So quite tricky. The trick is to visualize this and use your part A again, i.e. CA was pivotal to this question over here. If it didn't have this, we couldn't really work out AO because the parts would not be there. So that's your answer for part B.
So this is the final version of your maths memory card. Before we do our questions, let's look at these two learning objectives. So you should know how to look at and identify parallel lines. Basically, it means you want the same things in your two brackets. Okay, so create two separate equations and make sure you have the same direction on both of them, the same brackets. Ratios as well. We found a way of how to deal with these, adding up your numbers and creating boxes from this. That's a little trick as well. Your examples, again, I'll leave that to you to find out what your best example is on this video. We haven't created any steps on this because they're quite varied questions as we go along. But again, pause this and make sure you have got this. So here's our final revision card. This is how it should look like before we do our Let's Do It questions. Make sure we have parallel lines and ratios fully understood. We've gone through them thoroughly on this maths memory video. So press pause, get these two ideas down, and do these questions to see how well you can apply your knowledge from these core questions into these questions yourself.
Question 1, let's do it, basic vectors. So it's your turn to now take action and to use your revision cards to apply these basic concepts. The key concepts of ratio and parallel lines are the key things within this topic of maths memory. So write down parts A and B, press play for the answers when you're ready. Question 2, let's do it, basic vectors. So again, now you should be quite familiar with this. Let's write down parts A, B and C, and let's hone in to this topic of ratio and parallel lines. Make you an expert in this. So press pause and press play when you're ready for the answers.
Congratulations on finishing this topic, basic vectors. So let's rate yourself on your planner how well you have done. How well have you learned parallel lines and ratios in this kind of question? Rate yourself. I'm sure you've done really well.